Welcome to this video, which is a review of Pythagoras' theorem. Before I go into a couple of worked examples, I just wanted to go through what Pythagoras' theorem is and what it helps us to find. So, getting straight into it, what it says here is Pythagoras' theorem is used to find an unknown side length in a right-angled triangle. And I've underlined those two words because it's really important that the triangles we're working with when we apply Pythagoras' theorem have a right angle, and also that we're using the theorem or the formula to find an unknown side length. So, if I have a look up here at my Pythagoras' theorem formula, I just want to quickly go through what it means and why it works using this visual example here. So side length A and side length B, they are always my shortest two sides. Side length C is always my longest side, and in a right angled triangle, my longest side is always opposite that right angle, and we give it a special name which is called the hypotenuse. What this formula says is that if I take side length A and I square it, and then I take side length B and I square it, and I add side length A squared and B squared together, they are equal to side length C squared, which means I could actually take this square here and this square here and make it fit exactly into here. And that is why Pythagoras' theorem works, because my two shorter side lengths squared will always be able to fit into my hypotenuse squared, which is always the C value. So let's get into a couple of examples. Okay, this is my first example, and I'm going to go through two examples using different cases, and I would be writing down the difference between the two cases. So in this first case, we are given the two shorter side lengths in our triangle, this one here and this one here. And what I'm trying to find is that hypotenuse, or that longer side. So if I just label on here, this is my right angle, my hypotenuse is always directly opposite that. Okay. So before we said that our C value is always our hypotenuse. So C is always the hypotenuse. And then I need to label my other two sides, A and B. Now in this case, it doesn't matter which order I label them. So I'm just going to go ahead now and make this 8A and the 10B. Now what I can do is I can substitute in my values to this formula. So anywhere I see A, I'm going to change it to 8. So I've got 8 squared plus B squared, which was 10. 10 squared equals C squared, which is our unknown side length. So next I go through and I evaluate these numbers. So 8 squared is 64, and you could use a calculator for this, equals C squared. Add my two numbers together, 164 is equal to C squared. Now I want to get that C, this C by itself, but I've got this little squared symbol in the way. Now whenever we apply operations in an algebraic setting like we've got here, we're always trying to do the opposite operation. So if we had an addition, we apply subtraction. If we had a multiplication, we apply division. When we've got a squared, we actually apply a square root. So a square root undoes a square. And remember, I do that to both sides. So this square root has undone this square. And what I'm left with is C is equal to the square root of 164. And then what I do is I go ahead and I pop this into my calculator, and I'm going to round just to one decimal place here, and I get 12.8 centimetres equals C. And just remember that this C was actually labelled as K in here. So then I can say that side length K is equal to 12.8 centimetres. And that's my final answer. So that's case 1, when I'm given two shorter side lengths and I'm trying to find my hypotenuse. And you would follow this step using these steps using this formula if you were given your two shorter side lengths and you're trying to find the hypotenuse. Now let's have a look at case 2. Think about what's different. What are we given and what are we trying to find? So in case 2, we're actually given our hypotenuse. So I'll just label that right angle. We're given our hypotenuse and a shorter side length, and we're trying to find the other shorter side. And we use a slight variation on Pythagoras' formula to solve this. And all we've done is a manipulation on the previous formula, which was a squared plus b squared equals c squared. This is exactly the same thing. Bits have just been moved around, but I won't go too much into that and confuse you. So I'll label my C side because my hypotenuse is always my C. Oops. And then I need to be careful about what I label as A and B in this case, because this P here is what I'm trying to find. This P here is what I'm trying to find, which is on this side. So I'm actually going to label my unknown side length, this A value, to make it easier for myself. A, which makes this side length here B. Okay, and now it's very similar to the other formula or the other case. All we do is we go ahead and substitute in those values. So A we don't know. A squared equals C squared, so 22 squared, minus B squared, which is 8 squared. So be careful about this. Be careful with this minus here because this was a plus in our original formula. So just be really careful to properly substitute your values in and closely follow that formula. So I'm left with A squared equals 22 squared, which is 484. Subtract 64. A squared equals 420. Okay, so now I'm at that bit where I have to get rid of this squared here from this A. So if you remember from the last example, to undo a square, I square root both sides, and that's going to cancel this square here and the square root, and so I'm left with A is equal to the square root of 420. And then we pop that into our calculator, and again rounding to one decimal place, I'm left with A is equal to 20.5 centimetres. And if we have a look over here, this was really P, so I'm going to change that to a P. So P is equal to 20.5 centimetres. So what I would suggest that you do now is you go back, if you haven't already done so, and take notes on what Pythagoras' theorem is and write down the examples of each of the two cases before you go ahead and have a go at the worksheet. So I hope this helps. If you have any more questions, ask me. If not, get on with the worksheet, please.